inverse proportion, one of the common examples is speed multiplied by time is equal to distance. So if we have to cover a certain distance, and if the speed increases, then the time taken will be lesser, it will reduce, and if the speed reduces, then the time taken will increase. Now the question is, if we have a problem like say this, to cover a certain distance, the speed, if the speed increases by 20%, then by what percent will the time taken reduce? So let us try to understand this. Let us take some numbers for speed and time. Let us say the speed is 60 kilometers per hour and the time taken is say 3 hours. So the distance traveled would be 180 kilometers. Now it is said that the speed increases by 20%. So when the speed was 60, it was 100%. Now it has increased by 20%. So earlier it was 100 by 100. Now it has become 120 by 100. So the speed has increased by 20%. So the time has to reduce. The initial time was 3 hours, and now it has to reduce by something so that the distance remains the same, right? So here we have 60 multiplied by 120 divided by 100 times 3. So what should come in this place such that we have 180 on the right side? So 60 times 3 gives us 180. So ideally this fraction should get nullified. So with what should we multiply by 3 so that this gets nullified? So that will be the reciprocal of 120 by 100, which is 100 by 120. So if you multiply this by 100 by 120, then what happens is this 100 and 100 gets cancelled off, 120 and 120 gets cancelled off, and the result is 180. So now the speed has increased by 20%. So by what percentage will the time taken reduce? So the time taken has reduced by how much? The time taken has become 100 by 120 of 3. So what is this 100 by 120? It is nothing but 5 upon 6. Earlier it was 100 by 100, that is 3 times 100 upon 100. That was the speed when it was, that was the time when it was 100%. So now it has become 5 by 6. So earlier it was 1, now it has become 5 by 6. So it has reduced by something and it has become 5 by 6. So it has reduced by 1 by 6, and the resulting time is now 5 by 6 of the earlier time, and here this is 60 times 6 by 5, because 120 by 100 is nothing but 6 by 5. So when 20% is increased, when there is an increase of 20% in the speed, so initially the speed was 1, or rather the 100% was 1, and when 20% is increased, 20% is nothing but 1 by 5. So 1 plus 1 by 5 will give us 6 by 5, which is what happened here. The speed increased by 20% and the time taken will reduce by how much? So it has reduced by 1/6, right? The speed has increased by 1/5 and the time taken has reduced by 1/6. So when we say it has reduced by 1/6, this 1/6 is what percentage? So we know that 1 by 3 is 33.33%. So 1 by 6 should be half of 1/3, which is half of 33.33%, which is nothing but 16.67%. So the answer to this question would be, if the speed increases by 20%, then the time will reduce by 16.66 or 16.67%. Now there is a shorter way for doing this calculation. We don't have to go this far. What we need to remember is the speed multiplied by time is distance. Distance being constant, speed is increasing. So speed is increasing by 1/5 and time is decreasing by how much? So when the speed is increasing by 1/5, initially if the speed was 1, it becomes 6/5. So the speed has become 6/5 and the time has reduced by something. So the time has to reduce by something so that it becomes the reciprocal of 6/5, which is 5/6. So the time has to reduce by 1/6. Instead of this, let us take another example. Say if the speed increases by 25%, that is 1/4. If the speed increases by 1/4, what happens? This becomes 5/4. So the resulting speed is now 5/4 times the earlier speed, because it has increased by 25%. So the time has to reduce by something. So the time, initially it was 1 minus something, should result in the reciprocal of 5/4, which is 4/5. So the time has to reduce by 1/5, right? So as we can see here, when the speed increases by 1/5, the time reduces by 1/6. So if the speed increases by 1/4, then the time reduces by 1/5. So if the speed increases by say half, 50% increases by half, that means initially it was 1, now it has become 1 plus 1/2, so it has become 3/2. So time has to reduce by how much? So that it becomes reciprocal of 3/2. So time has to reduce by 1/3. So when the speed increases by half, the time reduces by 1/3. When the speed increases by 1/4, time reduces by 1/5. When the speed increases by 1/5, time reduces by 1/6. So we can say, if the speed increases by 1/a, then the time reduces by 1/a plus 1. So this particular relationship is very, very useful. So if we remember this relationship, then we can easily solve this particular question. So now let us look at the question again. If this was given 60 kilometers per hour, it increases by 20%. So the time has to reduce by how much? Actually this 63 and 180, this does not matter. The speed does not matter. This distance is constant. So if it is given that at a particular speed it takes 3 hours to cover a certain distance, and if the speed increases by 20%, we know that 20% is 1/5. So if the speed increases by 1/5, then the time has to decrease by 1/6. So we just have to reduce 1/6 from this particular number, that is 3. So 3 minus 1/6 of 3. So 3 will reduce by 1/6, or from 3, 1/6 of 3 will get reduced, or we can say 3 will become 5/6. So if you reduce 1 by 5, 1 by 6 from 3, this becomes 1 by 2. So 3 minus 1 by 2 has become our 5 by 2, right? So this has become 5 by 2. So 5 by 2 gets reduced, that is, this is nothing but 15 by 6. 15 by 6. If we just simplify this, it would be 3 5s are and 3 2s are. So it is nothing but one and the same, right? Okay. So with this particular relationship we can try to handle such problems. That is, if we instead of, okay, let us take one more example of speed, time and distance. And this time, instead of speed increasing, let us take speed reduces. So if the speed reduces by 25%, then the time will increase by what percent? So now here, earlier it was speed was increasing, so speed was increasing by 20% and the time decreased by 16.66%, or the speed increased by 1/5 and the time decreased by 1/6. So here we have the speed is decreasing by 1/4 and the time has to increase by how much? So the speed initially, if it was 1, it is decreasing by 1/4, so the resulting speed is 3/4 of the earlier speed. So the resultant time has to become the reciprocal. So 1 plus how much will give me 4 by 3. So what should I add to 1 so that it becomes 4 by 3? So I have to add 1 by 3 to 1 to get 4 by 3. So if the speed decreases by 1/4, then the time increases by 1/3. So the easy way is, if we have a particular percentage, we can just try converting that to fraction. So if the speed decreases by 1 by 5, then the time will increase by 1 by 4. If the speed decreases by 1 by a, the time will increase by 1 by a plus 1. So this relationship we can use for calculating speed, time, distance. The same thing we can use for even problems like price multiplied by quantity is equal to total price. So that is, if something used to come at a rupees per kg and we used to buy b kgs of that particular thing, so the total price would be AB. Now if the total price is not changing, so this total price is, let us say, something that I can afford for a particular month. So I can afford, say, b kgs of sugar at a rupees per kg. So the maximum that I can afford per month is AB rupees. So now AB rupees being the same, suppose the price of sugar goes up by 33.33%. So the price has gone up, but I cannot afford to pay more than AB in a month. So the price has gone up by 1/3. So the quantity, I will have to reduce my consumption. So my consumption has to reduce by how much? I will have to reduce by 1/4. Same. So initially price was 1, now it got increased by 1/3. So it has become 4 by 3. So now by how much will I have to reduce this? Initially it was 1 and now I have to reduce something so that I get the reciprocal of 4 by 3, which is 3 by 4. So I'll have to reduce 1/4 from it. So how much will reduce? 1/4 will reduce. How much will be